For our experiment, we did drop heights impact on splash dimensions by Jake Lang, Mike Keller, and Jake McKinnon. To expand from our previous experiment, we added a 100 milliliter balloon and a 300 milliliter balloon to the previous 200 milliliters to record more data. The purpose of our experiment was to discover how different drop heights and volumes impact how large the area of a water balloon splash will be. For the materials of the experiment, we used water balloons, a hose, a ladder, a javelin, a lacrosse stick, a measuring tape, and a measuring cup. For the procedure of our experiment, we filled up approximately 27 water balloons. We filled up 3 of each volume of 100 milliliters, 200 milliliters, and 3 milliliters for 3 trials at each height of 2 meters, 3.5 meters, and 5 meters. Then used the data we found to find our conclusion.
First trial, 100 milliliter balloon at height of 2 meters. $12 by 12. Second trial, 200 milliliters and the height of 3.5 meters. $19 by 20. Trial 1 with the 300 milliliter water balloon at a height of 5 meters. $20 inches by 23.
The data for our experiment was fairly consistent. As you can see here, as the height of the balloon drop increased, so did the area of the splash radius. This can be seen in all of the trials. As we increase from 100 milliliters to 200 milliliters, a double in the balloon's volume, the trend in constant increase in volume with increase in height stayed the same. However, the actual amount of area from the drops from 100 milliliters to 200 milliliters are very different in that the 200 milliliters have much larger splash radius. When we once again increased the volume from 200 milliliters to 300 milliliters, the trend in that the area of the splash increases with the increase in height continued. However, this is where, or as we expected, this is where we found our greatest splash areas. As you can see here in this graph, where the average splash area is on the vertical axis and the drop height is on the horizontal axis, splash area in square meters and height in meters, you can see the drop heights and volumes side by side. As you can see, the increase in splash area from 2 meters to 3.5 meters is greater than that of 3.5 meters to 5 meters. This isn't due to necessarily to the drop height, but due to the impact velocity. The impact velocity changes more from 2 meters to 3.5 meters than it does from 3.5 meters to 5 meters. This change in impact velocity is what accounts for the splash area change. If we made it so that the area or the impact velocity changes equally from each trial, you would have likely see a linear change in the splash area.
For the conclusion of our experiment, we found that the higher the water balloon is dropped from, the larger the splash dimensions will be. and the more volume the water balloon had, the larger the splash area will be. Thank you for watching, and have a great day, and we out!